scientists and engineers. Miss Bobby here. We've been learning a lot about mixtures. We've been learning about solutions and suspensions. In this video, I'm going to talk to you about what happens when you mix two chemicals. We know that substances have a special characteristic called solubility, and that depends on the particular chemical makeup of the compound or the substance, and also what you're trying to dissolve it in. So we're going to be using things that you probably can find around your house, and we're going to be using water for our solvent. I'm going to be showing you the results of the experiment that we designed in class. I'm going to be showing you the procedures, and then how I followed them, and then what happens when you mix certain chemicals together. And those results depend not just on their solubility, but also about other chemical characteristics. So I hope you'll enjoy this video. And so let's get going today.
First, let's look at the experiment that we designed together in class. We're using the scientific method. Remember, question, test, report. We're testing the solubility of three substances, salt, sugar, and sand, and we're using the solvent water. We're also comparing what happens with solubility with warm water or cold water. We decided that there were 4 questions we wanted to answer. What's the solubility of the substances? Which one is the most soluble? Can we make a liquid solution with all 3 substances? And how does temperature affect solubility? For our first question, we're going to put the same amount of substance in each of the test containers with equal amounts of water and observe to see if they dissolve. Then we're going to add more substance a little at a time if it doesn't. We're going to write down what happens, and we're going to find out which hypothesis was correct. Here's a picture of the experimental setup. You can see that I have a lot of measuring devices. I wanted to show you that you don't necessarily need things like the measuring spoons. You can still go ahead and do this experiment. I used a measuring cup, and you can see that I have 100 milliliters of water in it for our solvent. This is what 1/4 teaspoon of any of the substances look like. I'm going to put it in the bowl and then add the water. When I added the water, some of it dissolved. It looks like the sugar and the salt both dissolve, but it's clear that the sand did not. Now we know the correct hypothesis is that not all substances have the same solubility. We'll keep adding 1/4 teaspoons of salt and sugar until they no longer dissolve. We'll keep track of how much we added on a piece of paper for each of the substances. The salt finally stopped dissolving after we'd added about 1 teaspoon. The sugar was still dissolving even after many teaspoons, and the sand never dissolved at all, even after only 1/4 of a teaspoon. You can tell by looking at our data sheet that sugar is clearly the most soluble. I started adding sugar about 1/4 of a cup at a time. To figure out which substance is most soluble, we'll record the amount of each substance that we dissolved in the water, and the test container with the most amount of substance is going to be the most soluble. Then we're going to write down which of our hypotheses is correct. It took so much sugar to dissolve in our 100 milliliters of water that it even expanded the total volume to 200 milliliters. Sugar is clearly the most soluble substance of our three. To figure out whether or not we can make a liquid solution with all three substances put together, we're going to measure an equal amount of each of the three substances into a container. We're going to add water and then observe what happens and record the results. Then we'll figure out which hypothesis is correct. I measured out 3 tablespoons of each of the solutions, then mixed it around. We remember that the sand never dissolved, so we might have expected this would not form a solution. And that's exactly what happened. So, for our third question, it turns out that the hypothesis that says no, you can't make a solution, but you can still make a suspension was the correct hypothesis. Our last question was whether temperature affects solubility. We would take a saturated solution, one where no more of the substance would dissolve, in room temperature water, and then heat it up and see whether or not more of the substance would dissolve. Let's see what happened. First, I took the salt water solution at room temperature and added 1/4 teaspoon of salt. I heated the solution for 30 seconds in the microwave, and not much happened. So it seems that with salt, adding much heat doesn't seem to change the solubility of salt. Then I started testing the sugar solution. I added more and more sugar, about 1/4 cup at a time, and just stirred it around until I could get a saturated sugar solution. When I heated it up in the microwave for 30 seconds, the 1/4 cup sugar that I added dissolved. So sugar is clearly very more soluble in warm water. This makes this substance very different than the salt. So now we know not all substances are affected by the temperature of their solvent. So our results show that for the first hypothesis, the water solubilities of salt, sugar, and sand are not the same. For our second hypothesis, sugar is the most water-soluble substance that we tested. For our third hypothesis, no, we can't make a solution, but we can make a suspension mixing salt, sugar, and sand. For our last question, we didn't test whether sand would dissolve in hot water, but we know from experience that it doesn't. We found that salt does not change solubility when the water is heated, but sugar definitely increases solubility when the water is warmed.
Hi, scientists and engineers. Miss Bobby again. Thanks for joining me today and finding out how our solubility experiment turned out, the one that we designed in class. The next video is going to be about reactions, and I'll be introducing that video very soon. Thanks. Bye.